Hi guys, in this video I'm going to use Microsoft Excel to demonstrate kNN, k nearest neighbors. That's a machine algorithm that's used for classification / prediction of a categorical target feature. So basically, first thing I want to do is start talking about our data set, and I've purposely chosen a small and manageable data set so that we can really demonstrate how kNN works fundamentally. And when you actually perform this, you may have many more features and many more examples than what I'm displaying here. So, and then it becomes quite difficult to visualize what's actually going on. So I've purposely chosen a three feature data set, and I am telling you that our goal here is to classify the species of these flowers. So these examples are each attributes or features of a flower. So this right here is a flower which has a sepal length of 5.3, a sepal width of 3.7, and its species we know. In other words, it's labeled Setosa. And we have 15 of these labeled examples, and this collectively it can be called our training data set. Okay? So again, one more time, these are labeled examples because we know the target feature values. So here is our target. That's what we want to predict. Okay? So now let me just flip through to another sheet. This is the same data, but I've set up this sheet a little bit to kind of walk us through the process. Okay, so first off, so to get a good idea of what we're doing, why we're doing it, before we jump into doing some plots and some calculations. Okay, so here's our data set once again. These are our labeled examples. We have 15 labeled examples. Our target feature is species, and then we have two other features. We could call those predictor features, sepal length and sepal width. They're both numerical. That will make our lives a little easier in this introductory video. Okay. Now in this next section here, I've put some kind of comments here. So let's read these. A new flower is found, and we need to classify this flower. So it is unlabeled. We don't know the species of this flower, but we do know its sepal length and its sepal width. So what we want to know is, or what we want to do is come up with a systematic way to classify its target, which in this case is species. So I want to be able to, at the end of this whole tutorial, I want to come up with a prediction for the class of species that this particular flower is in. Okay, so either Setosa, Virginica, or versicolor. If you look through the species, those are our three choices. Of course, this is a simplified example. Okay, so first thing we want to do before we start moving into calculating distances and coming up with the nearest neighbors, I want to make a plot of this. So I purposely made this three features, one of them being the target, of course. We'll set that aside for a second, and two predictors, because this we can very easily visualize and understand what's going on when we do a k-nearest neighbor algorithm. So what the algorithm is doing. So let me flip back to this sheet where I have some room, and I'm going to make a scatter plot. It doesn't really matter which of these variables I put on my x or my y, so it does not matter. I'm going to insert a scatter plot. Okay, and it suggests something, and I'm going to start from scratch. Select data, remove. Okay, and I'm going to add x. Well, let's put width on the x-axis. Let's put length on the y-axis. Let's remember we did that. Let's adjust things a little. We don't need a chart title. We don't need these grid lines. we need axis titles, and we also need to adjust these axes a bit. So I don't need to start from 0, right? I can start from 2 here. And on this axis, I'm just cleaning up my plot so it just looks a little tidy. It's purely optional. And I want to do the same thing for the y-axis. I don't need this area down here. So I'm going to start that at about 4. Should be good. Yeah, much cleaner. Okay, I'm going to label my axes. So we put sepal width down here and sepal length on the y-axis, and I could kind of square this out a bit. Okay, so we should have 15 points here. Each of these points correspond to one of these flowers, and we have 15 flowers. Examples, right? Training data. So this is a visualization of our training data. It would be really nice if I can get the labels of the target feature on each of these points as well. So to do that, I'm going to click on the points, I'm going to right click, I'm going to go to add data labels, I'm going to add data labels. By default, it's just going to add the Y values. I'm going to change that by clicking on them, right clicking, and saying format data labels. Okay, you could play around with this a lot, but I'm going to do what we really want. I want the series, I want the values from cells, and I can highlight the target feature labels, click OK, uncheck the Y and leader lines, and now I have the labels of all the points next to them. I can kind of adjust the font size, so you should play around with this a bit till you get this to where you want it. You can change your point colors and so on and so forth. Okay, so it's a little messy. We can format this and put them above, put them to the right, put them to the left, put them center. Center seems to be good. Okay, it's a little messy, but it's if we really want to, we can make out which species each of these points represents. So I have a cluster of 3 virginicas up here. I got a cluster of a bunch of setosas down here. I got a cluster of a bunch of versicolors, and there's one virginica sneaking in over here. So generally, you see there seems to be a conglomeration of the different species at different parts, at different coordinates or areas of this plotting that we're doing. Okay, and that's great. Okay, so another thing we want to add to this plot is a point for that new unlabeled example. So that guy was over here, this guy, right? So to go to make him appear over here, click on the chart, select data. We're going to add a new series, and this series is just going to have one x value and one y. So the x is the width, right? And the y was the length. So that's we can't mess that up. All right. Nice. Got that right? Okay. Here he is. That's our new guy. Okay? That's our unlabeled flower. These guys are all labeled. Okay? So kNN works like this in its simplest form without adding complications of using categorical variables and rescaling of variables. These are definitely things to consider once you've understood the fundamental concepts. Basically, the way the algorithm works, and we're seeing it here visually, which is great, is it's going to find the k closest points to the point that you're trying to classify. So I'm talking points, I'm talking visual, right? So here's the point we want to classify. So what are the k closest points to it? Well, clearly we have to define k. We have to choose k, and that's a parameter that we get to play with in kNN. Typical values for k, there's no right answer, but typical values for k, rule of thumb would be to take the square root of the number of examples you have in your training data set. So we have 15 examples. We might take the square root of 15 and end up with anywhere from 3 to 4. So k equals 3 or k equal to 4 would be decent choices here, okay? And you could even try both of them, okay? So let's say we chose k equals 3. So we're looking at the distance. So here's the distance from our unlabeled example to this particular example. Here's the distance, so let's call that distance 1, okay? Here is the distance. I'm drawing little brackets, so to distance to another example, distance 2. Here's the distance to another example, so distance 3. And I could keep doing this till I've gotten in this case, all 15 examples Euclidean distance to our unlabeled example. Okay, so I could keep drawing these brackets. So these are Euclidean distances, okay? And the order that I'm doing these does not matter here. The point is we're going to end up doing this for all of the examples in our training data set. We're going to get the Euclidean distance from our unlabeled example to each of the examples in the training set. Okay, so we're going to end up with 15 Euclidean distances. And visually what we're going to be doing is all these brackets that I'm drawing. Okay, and then once we have all these distances, all the distances from our unlabeled example, this guy, remember that's this guy, to each of these labeled examples from our training set, then we can choose the k closest. Then we're going to choose the k closest. So if we set k to 3, let's choose 3. We're going to choose the 3 closest examples to our unlabeled example, and we're going to do a majority voting on the species of those 3 and use whichever species is the majority of those closest 3 to classify / predict our unlabeled example, this guy. Okay, so visually we kind of can see that the 3 closest seem to be, well, that's definitely the closest, that's definitely the second closest. Now the third closest is kind of close. It's either that guy or that guy, okay? So this kind of, let's just say it's this guy. It's very close. So in this case, the 3 closest would all be setosa, so the majority vote would be setosa. So we would end up classifying our guy as setosa, and that would be our ultimate goal here, okay? All right, so let's actually get that done. Okay, so visually that's what we're doing, but we have to actually do that with the numerically with the data set and values that we have. So I've set up this third section here to do that. So ignore this column for a second. In this column we're going to get the Euclidean distances from each of these examples to our unlabeled example. So what's Euclidean distance? Well, distance between 2 points. So let's very quick review. It's distance between 2 points. So let's just leave that. XY, let's say. And here it is simply XY because we just have 2 predictor features. Is the square root, so a big old square root of x1 minus x2 squared plus y1 minus y2 squared. And if this was in 3 dimensions, in other words, we had another predictor feature, then we would just continue plus z1 minus z2 squared, and so forth. Maybe I should change these to 0.1 and 0.2. So scratch that. So in parentheses here, 0.1 comma 0.2. Okay, so basically if I want the distance between this point and this point, I subtract 5.3 from 5.2, that would be here, square that difference. Then I would subtract 3.7 from 3.1, that would be here, and square that difference. Then I would add the two and then take the square root, and I would get the Euclidean distance between the 2 points. Say that was those were the 2 points. That's how I would get this distance. Okay? So let's do that, and let's use Excel and let it do all the heavy lifting. So equals SQRT does square root, open parentheses. I'm going to open another parentheses. I'm going to do this guy minus this guy. So I'm doing the sepal length minus the sepal length. I'm going to lock this guy because he's not going to, this is not going to change as I do all of these, whereas these I want to change. So you got to be a little bit familiar with Excel to see when I'm using these dollar signs, the absolute references, and when I'm using relative references. Okay, so that's a totally separate issue here. Okay, so I'm going to square that plus, open parentheses, sepal width of the first example minus the sepal width of the unlabeled example. I'm going to lock that. I'm hitting the F4 key on my keyboard to quickly lock the cell. I'm going to square that, and that's it. Close the square root parentheses, hit enter. This is the distance between this example and this example. Okay? And I'm going to continue to do this distance from this guy to this guy. I'm going to put that here. Distance of this guy to this guy. I'm going to put that here. All the way down to the distance from the last example to this guy, and that's going to go on the row, same row as that guy. And then I'm going to have all the distances, Euclidean distances. Okay? I don't need to do that over because I set up my formula properly, so I can just drag that down. I can kind of minimize the number of decimal places. So we could just quickly glance here. The closest point looks like this guy, and the furthest point looks like this guy. Okay? We don't need to use our eyeballs too much on this because I'm going to use a formula here called rank that is going to rank each one of these guys and tell us ascendingly which is the closest. So that's the third closest. Here's the closest, exactly the one we thought would be the closest, right? Here is the furthest, exactly the one we eyeballed to be the furthest. Okay, so again, that was rank. I'm going to rank the distance. I'm going to rank it in this array. I'm going to lock that array so that doesn't change when I drag the formula down. And then I'm going to choose 1 for rank ascendingly. Okay, and then I just drag that down. So I have all the rankings now. Next, I want to get the labels for each of these ranks. So that's simply just copying basically that column here. Okay, so if I just stop here, I could see the closest to our unlabeled example is a Setosa species. By the way, if we go back to the plot, that's definitely this one. Okay, And the second closest to our unlabeled example was also setosa, and the third closest was also setosa. So if I'm doing k equals 3, it's clear that the majority of those 3 are setosa. It's a no-brainer. We would classify this flower as a setosa. Okay, but let's go through with it. Here, because I'm chose to do k equals 3, okay, I am going to set up the first, second, and third rank and pull in the labels for those. So to do that, I'm going to get a little fancy. I'm going to do a VLOOKUP. I'm going to VLOOKUP this guy. So equals VLOOKUP. I'm going to look up the number 1 in this table. I'm going to lock that table. When it finds it, I want the label, so I want the third column. So if you don't know VLOOKUPs, you need to watch my video on VLOOKUPs. So go to my channel. I have a bunch of videos teaching you Microsoft Excel in fundamentals all the way on up to using it for different purposes, like this tutorial where we're using Microsoft Excel as a tool to learn how kNN works. Okay, so I tell it 3 to give me the third column, and I tell it false to give me an exact match. If I hit enter, it's going to find the number 1 in this table, and when it does, it's going to give me the third column, and that's why I get setosa. And once I set that up, I could drag that down, and it's going to do the same thing. It's going to look for number 2, and it's going to give me the third column. It's going to look for number 3, and it's going to give me the third column. In this case, they all turn out to be setosa. So the 3 closest to our unlabeled example were all setosa flowers species. So what do you think we're going to classify our new flower as? Setosa. Okay? And that's basically how the kNN machine learning algorithm works. Now, you could play around with k. You could choose a k of 4, and you could get the 4th closest. Right? Since I set that formula right, the 4th closest turns out to be versicolor. Probably this guy. Right? And still, the majority vote would give the win to setosa. So still, we would end up labeling setosa. Okay? So here the answer is setosa. Okay? So would you do this in Microsoft Excel like I did? Probably only to understand what's going on and get a good grasp of what kNN does. But once you have a big data set, this could become quite cumbersome to do. So there are plugins for Excel. There's R. I personally use R to do this stuff. You can use Python, probably any programming language to perform this. But I would recommend R for this. Okay? Some kind of final points to make here. This was a very simple example. As soon as you have more features, for example, I have more features here. So let me just call them x3, x4, x5. Okay? Now all of a sudden, I cannot visualize these the way I was able to visualize when I just had 2. Right? Because all of a sudden here I'm in 3 dimensions, and then here I'm in 4 and 5, and we can no longer get a good visual grasp of what's going on. So that's why I chose just 1 target and 2 predictor features. Another thing I want to point out is if the scale of one of your predictor features is larger or bigger than the others, it can have an undue influence on the distance calculations that we do here. So in kNN, you should rescale your features before you start these distance calculations. Okay, so there's a couple choices of that. One way is to normalize, one is to standardize. So basically you can adjust the ranges without losing the information. Okay, so that's something to look into as you start doing kNN. Another thing is kNN can also handle categorical nominal features, things like gender and stuff like that. It just needs to, again, it needs some adjustment and rescaling. Okay, so there are other ways to rescale. So once you're in that situation, you'll kind of have to do a little pre-processing before you get to this stage of calculating distances and ranking. Okay, there are different forms of distance that you can calculate. There's Manhattan distance, cosine distance, and other ways to calculate distance. So we simply use the most common, which is Euclidean. Alright, so I hope this video was helpful and it gave you a grasp of what kNN is doing. These machine learning algorithms are quite intuitive and you feel a lot better about them when you understand what they're doing. Once you start getting very active and employing these things, they're going to be almost black boxes where one line of code and everything goes on behind the scenes and you just get the kind of final output. Okay, so it's nice to know what's going on. So I hope this was helpful. Please subscribe, like, and share the video, and be sure to check out my channel. I have tons of other videos, including how to do kNN in R. Okay, so till next time, have a great day.